Our next speaker is Angel Badewole, who is a PhD student at the Department of Chemical Engineering and Applied Chemistry, with a talk titled Assessing the Environmental Impacts of an Innovative Chemical Production Pathway.
Shampoo, brake fluid, and cleaning products. Are you wondering what these have in common? You're probably thinking, oh, these are just items I have at home. Well, if you guessed that, you'd be absolutely correct. But I'll tell you what else they have in common. These are all made using ethylene oxide. Now, if you're not familiar, ethylene oxide is a chemical used to produce a wide range of everyday products such as these. Now, I'm sure we cannot imagine our homes without cleaning products, so evidently this is a vital chemical. However, the current method of producing it, as shown on the top left, relies on fossil fuels and leads to a release of large amounts of greenhouse gases. These are gases such as carbon dioxide or CO2, which when released into the atmosphere have an adverse effect on our climate. Now, this has led to a race to develop innovative pathways to produce chemicals without relying on fossil fuels. But caution needs to be exercised here, because some of these new pathways inadvertently exacerbate the very environmental challenge they attempt to solve. So in my research, I tried to prevent this by assessing the potential impacts of such new pathways before they're deployed on a large scale. Recently, I collaborated with researchers who developed a new pathway to produce ethylene oxide. As shown on the top right, this pathway relies on electricity and actually takes CO2 away from the atmosphere for use as a raw material. So here's what I did. I calculated the greenhouse gas emissions from this pathway by performing a life cycle assessment. Now, to briefly explain, this involves examining the environmental impacts associated with all aspects of a product's life. So starting with the acquisition of raw materials, all the way to the final disposal of the product. And I did this by collecting data on the raw materials used in the process and then calculating the corresponding emissions associated with sourcing and using these raw materials. My objective here was twofold. One, of course, to calculate the greenhouse gas emissions like I said earlier, but also two, to compare the conventional fossil-based route with the innovating electricity-powered route of producing ethylene oxide from an environmental perspective. Now, I'm sure you're all curious to hear what I found. The results of my assessment showed that although this new pathway has promise, it does not currently offer lower emissions relative to the fossil-based route. But I was able to show the technology developers key areas for improvement in their process, such as reducing their energy demand in order to reduce their emissions in the future. Now, as I conclude, let me be clear that these results don't indicate that we should be complacent about the current level of emissions just because this new pathway does not presently have lower emissions than the fossil-based route. Rather, my work highlights the gap that needs to be filled in order to move us a step closer towards our goal of decarbonizing the chemical sector. Thank you.